Integrals involving two brothers. So in this video, I basically have cosine integral function and cos function, their product, which you have to integrate from 0 to infinity. So let me share the definition of cosine integral function. Ci of x is negative of integral from x to infinity of cos t by t dt. Now this definition has been carefully made such that this integral also converges, and not just that, also the derivative of the cosine integral function will just be cos x by x. So these two are the main criteria that would have been satisfied while making this definition, and so it will be easier for us to deal with. Now let's go to this integral. We have this integral. Now the way we can simplify it is using integration by parts, with this as u and this as b. So we have cix, and the integral of cos px is sine px by p, and then minus integral from 0 to infinity. Derivative of ci function is just cos x by x, as I told earlier, and its integral will just be sine px by p dx. And now this goes from 0 to infinity. So at infinity, ci function is just 0, as you can see from here. So, and this is between 0 and 1, so 0 and 1, 0 and my 1 and minus 1. So some number n times 0 is just 0, minus, and then sine of 0 is 0, and this is again some number, so 0 times some number is also 0, and then minus 1 by p, and integral from 0 to infinity cos of x sine of px by x dx. Okay, now what can we do? We can basically use the sum to product formula of trigonometric ratios. That gives us integral from 0 to infinity. This is sine of p plus 1x, and then plus sine of p minus 1x. Divided by x dx. Okay, now good. So now we have minus 1 by 2p, and then now you need to know that integral from 0 to infinity of sine ax by x dx. This is pi by 2 if a is positive. If a is 0, then this will just be 0 itself. If a is negative, this integral will be minus pi by 2. And this is basically just a well-known integral. These values are just well-known, so we will make use of that. So now over here, why I have pasted the same thing? Delete this. Okay. Now over here, the values will depend upon either if p is this will basically let us say that p is a positive number as well. P is positive number. Okay, since p is positive number, the thing over here will always be positive, no doubt what p is. P plus 1 will always be positive. But over here it depends on condition. If p is greater than 1, then only p minus 1 is positive. If p is 1, then p minus 1 is 0. If p is less than 1, then this thing is negative. So the value of the integral depends on the cases. While p is greater than 1, in the both cases we will just have pi by 2 plus pi by 2. When p is 1, this will go to 0, and we just have this result, which is pi by 2. And when p is less than 1, this will be negative, so we have pi by 2 minus pi by 2. Yeah. So that means for p greater than 1, this integral will just be pi. For p equals to 1, this integral will be pi by 2. For p less than 1, this integral will be 0. Yes. So our answers will also depend on the cases. Yeah. So that means that the answer of this integral will basically be minus pi by 2p if p is greater than 1, and minus pi by 4p if p is 1, and 0 if p is less than 1. But in all the cases, basically p should be positive. Yeah. So this was the solution of this integral. This just involved this famous integral, which is basically known as, I guess, Dirichlet integral. I guess. Yeah, you can search it in YouTube or anywhere, and it's well known. So that's why I upload the result. And to talk about the flow, just use integration by parts and use product to sum formula of trigonometric values, and we get the answer. So that was it. It was quite simple enough. Yeah, and hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.